Thank you very much for joining this morning. I'm Matthew McCullough, and I have Brent Beer with me here in the background offering tons of advice, inputs, and questions as we go through these materials. But I hope that you'll really enjoy this power-packed 40 or 45 minutes of materials in which I'm going to demonstrate and showcase a lot of the things that, to me, makes Git and GitHub just such a useful tool. I am a developer by trade, having worked in the Java platform and Objective-C and C and MFC and COM and DCOM and just all these sorted things over the last 15 years. And I say from my own experience as a developer, not just a teacher, this is one of the most amazing transformations for me of any materials that I have ever had the privilege to work with. And I'll like to showcase what exactly I mean by that through lots of demonstrations and very little philosophical talking. Brent and I are able to be reached after this class by these addresses that you see on your screen. GitHub Training is our Twitter handle. You can @tweet us with something small there. Training@github.com is our email address where you can inquire about the other types of classes that we teach. Training.github.com is our website where we have linked to all of the free classes that we offer. We have some other ones forthcoming, and Brent is going to teach our next one in December. GitHub Training is our GitHub handle, and we have some sample practice repos and other materials sitting beneath that username at github.com. I'll keep it very brief about the two of us because I want to get into the materials, and what you should be seeing now is a short overview of kind of my background. I'm passionate about Git and GitHub. I've been teaching Git for about 5 years now, which is practically longer than GitHub has existed. So this is something that is extremely important to me, and I'm delighted that I have the employment opportunity to work with Git and GitHub daily and teach it to people as an actual job. My colleague who is in the background answering your chat questions in the Q&A window is Brent Beer, and he is a recent addition to helping out the training team with our classes, and it is absolutely a delight to have his help. He is an expert at Git. Don't let him be too modest with you. Ask anything in the background, and he will absolutely be able to answer that for you or queue up an answer for office hours. But our topics that we're here for today are Git and GitHub, and I want to waste no time in getting right to the core of these. We're actually going to be mentioning two discrete topics today, and that is both Git and then Git combined with GitHub, so kind of a sandwich in the middle, and then GitHub on its own as a web service that sits atop a collaboration model of working with software. Now, these pieces that we're talking about, this GitHub sandwich, and then GitHub, actually all play to developing software. But the roadmap that I'd like to establish for us of the material that we'll cover in these next 40 minutes or so is why you'd even choose this tool and where it's come from. A little bit of the setup to show you that it is very approachable. It's very, very easy to get started with this. And a little bit of a recipe on how to use this, kind of your first steps in getting started with a repository. And then a first couple of steps and recipe for using GitHub. So let's dive right in. Why would you even choose this? And why would you switch to a different version control system? It is a very valid question. And in fact, when I'm giving talks at conferences, I ask people and challenge them, don't take my word for switching to any tool, nor anyone else's who's presenting. Question it and ask, why would you waste or spend or invest the time in learning a new tool? If you're already using, say, CVS, Perforce, ClearCase, or Subversion today, this is an investment that you're going to have to toggle over to this new way of thinking. Now, when you think about switching, there's actually someone who's paved this road for you. The Linux development world was using BitKeeper, a commercial version control system, and that license was taken back from them. Strange enough that they were using a commercial tool, but when that license to BitKeeper was removed, unlike many of us who would say, well, what else is out there? What could I use? What else could I switch to? Instead, given that Linus Torvalds is at the helm of the Linux kernel and its development, he instead said, I'm going to invent my own. That's a pretty interesting response and a pretty bold one at that. But he succeeded. By many people's measures and the millions of people that are using Git today, it is the next step in terms of version control. It adds all of the attributes of distributed version control systems, which means that it works in both a on-machine kind of idea, as well as in the collaborative model that we've thought of having a centralized repo that's accessible over the network. It serves both modes extremely well. Now, I'll actually speak very politely of all these other version control systems that I've used in the past. I've generally had a pretty good experience with Perforce and Subversion, ClearCase, CVS, PVCS, these things that I've used in my software development career, but I'm still very open-minded to switching to something new if it has a lot of new benefits, features, performance, speed, and matching with the software development models of today. Git is one of the version control systems that's been developed in the internet era. And by that, I mean it works extremely well with high latency networks and sometimes even well with ones that have very constrained bandwidth, which you say, maybe that's strange. We're in the era of T1 lines and DSL to everybody's home, but at the same time, that's not the mode that we always work in. Sometimes tethered over poor Wi-Fi, spotty connections, maybe even tethered to your mobile device. So I want a tool that's going to work efficiently even in resource-constrained environments. By that, I mean that it has a very small footprint, both on disk and in memory. I'll show you that actually firsthand. And I'd also state that it's simple. People have a very argumentative state about mode of responding to me saying that this is a simple tool. But what I think they mistake, just like, let's say, the world of cooking or any particular sport, is that it's simple to get started, but there is a massive battery of materials that you can learn. In fact, 5 years in, this being my primary job, there are still little things that I learn about Git each and every month. So we'll start with the basics, and you'll believe that it is indeed simple, but you'll also say, oh my goodness, there is a wealth of features and skills and tools that can fit into this that I could learn over the next couple of months and years. The last little piece actually comes from its Unix and Linux roots. That is that these small programs are composable. Git is actually built of some very, very small programs that work cohesively together to create the appearance of a suite of tools. This means that since the little pieces are still exposed to you, if you're a person who likes to build up new ways of using tools, new recipes, new order and sequence of instructions, you can compose these with a batch script, a bash script, a Z shell script, a PowerShell script. These would all be ways to write your own new Git instructions. Now, with that little intro as to why we're using this, I'll immediately point over to setting up Git because I would love for the fact that the hour after this class was you just getting this all working and running your first few practice repositories. And I'm going to give you everything you need to make that possible. Setting up Git is really just running an installer, but even more raw than that, you could actually just copy and paste the binaries onto your path environment variable. I'm serious. It doesn't necessarily need registry entries or some invasive putting itself into the key store. You could literally just work in a portable mode with the binaries being on your path. No administrative privileges required. Now, the installers make it pleasant, and there's an easy enough place to get the help to do that. We have a page that we all at GitHub maintain that shows you how to actually set up Git for each of those platforms, and you can find that right at the top of help.github.com. The reason that I point out to that is we're constantly updating it and maintaining it for the new dot releases and the little differences that come up for the newest versions of Windows and Mac OS and Linux. So that's your home page for getting the step-by-step and screenshot-by-screenshot set of instructions for setting this tool up. Now, I've actually got this already set up on my machine. I've used one of the installers to accomplish that, but I want to show very, very early over in my terminal window, clearing off this terminal screen right over here, and typing git -- version to show you that I'm at version 1.8.0. I'll emphasize again that while part of my demonstration today is going to be in Mac and part of my demonstration is going to be on a live running version of Windows, this actually serves the star Linux, Unix community very, very well. That's its home, that's its roots, that's where the copies of the new versions are first published, and then quickly thereafter, sometimes hours, sometimes days after, the Mac and the Windows versions emerge from that core Linux distribution. So there's my test. I have Git up and running, but you ask, what could be next after that? Well, we have to use it next. And literally, I mean, that's all there is to actually getting Git running the installer, going to your command prompt, and then firing it up. Now, many of you may already be asking, GUIs, I'm going to prefer to use this inside Eclipse or Visual Studio or a standalone IDE. And I'll show you some of those options as we proceed through this webinar. But I want to start by again emphasizing that this is a command line tool. Now, that is not to say at the detriment to any of the GUIs, but it is absolutely a command line tool from a scriptability standpoint. And that's important. As you work more towards a continuous integration and continuous delivery model of shipping your software, you will appreciate that the command line is a first-class citizen, not some sort of afterthought that has a horrible API. It's the core of Git, and the user interfaces simply leverage that command line interface, and in general are very consistent because the power of the tool starts from the command line itself. Now, we need to create a Git repository to do something actually useful with this. And this is an absolute inversion of the usual way of thinking about version control. Because if you have a small project, let's say the little ones that I start up all the time, maybe a little series of class notes, maybe a small book or pamphlet that I'm writing, maybe an article for a magazine, maybe even some documentation for a software project. The model of yesteryear for me was to send some sort of ticket in a ticket tracking system and ask a privileged administrator to create that repository. But in this case, I'm going to create this repository locally and then find a place to put it on the network, whether inside our company firewall or perhaps even on a public service like github.com. After the fact, I can switch the direction of this creation and then later publishing, and it will preserve all of the history that I create locally when I later push it to the network for the very first time. Let's head back to our command prompt, and here we are sitting again after having typed git -- version, and we'll clear off our screen once again. We're going to type a few instructions here, and the first one that I want to do is git init, and I'm going to call this project 1. When I've typed git init project 1, I have done something pretty impressive, which is to instantaneously create a local repository, but with no server or any daemon running in the background. There's nothing in the background. It simply used the file system to create a top-level directory called project 1, and then a nested folder beneath it called .git. Now I'm going to cd into that project, and I'm going to show you that by default, .folders on *nix systems are hidden. They're kind of considered a control structure, but that's no reason for us to hold back on peering inside what's in .git. Now, you might think for an introductory class, you'd say, would you ever poke inside the control structures of a version control system? But I encourage you to do so because they are quite user serviceable. I'm going to pipe this through more to show you this contents here. It's a small set. Wow, it didn't even have to run off the end of my screen. I have .git, a folder, with some files in it called head, config, description, a series of files that are called hooks. Those are lifecycle management kind of instructions that I can hook into with Ruby, Perl, Python. I could even hook in with Groovy or shell scripts or batch files and have it do special behaviors at the time that I write commits or update my repo. I then have a series of directories, info, objects, and refs, and those are where the actual data for the commits, the version-controlled, time-stamped copies of the repository, are to be stored. So this is the control structure. I'll already emphasize, if you've come from CVS or, say, Subversion, that there is one and only one .git folder per repository, and it is at the top level of the project. It does not repeat .git directories down all of your other folders. And in fact, if you ever wanted to un-git version a certain directory or project, just delete the .git folder. That's it. There's nothing more. There's no other tendrils. That's it. So for the moment, here at our macOS terminal, but these instructions being consistent across any prompt that you type, Git has created a repository. But clearing off my screen, I don't have any files as of yet. In fact, typing git status will let me see that I'm at the initial commit on a default branch that is called master. I have nothing to commit at this point because there's no files in here yet. So let's remedy that. Let's open up a text editor. Let's open up our TextMate editor, in my case, or any text editor that you like, against a file that I call first.txt. And I'm going to bring this onto your screen here in just a moment. We're going to drag this on as a visual text editor right over here. And I'm going to put in some lorem ipsum text into this file. So file and save, and I've written out this text. And now what next? Well, we'll ask Git what it thinks about the status of this current directory. First.txt is an untracked file, and that's the important word that you should be focusing on right here. Git tracks content. Each time that you type git status or you refresh one of the GUIs, it is in fact examining the current working directory and all of the directories beneath it to see if any files have either been modified or have appeared that it has never seen before. That's exactly the case for this first.txt, and it means that we can now add this file to version control. But adding this file to version control is still yet a surprise and a difference from the way that you work with version control today, because adding it is merely indicating that we want it to participate in the next transactional change set. Git add is a suggestion to have this participate. It's not yet a permanent record of that file. We finish that off with a git status to check that it is now transitioned to be a changes to be committed. The file's color is even changed for consoles that support that. I'll then take the next step of writing git commit, and I'm going to supply my commit message right here on the command line and call it my first commit. A very, very simple commit message. I would usually be a bit more verbose, but sufficient nonetheless. It says that I've made a commit to the master branch. I'll highlight each of these elements for you. It is the root commit. It has this globally unique identifier. And to be precise, it's the first 7 characters of that globally unique identifier. And it is my first commit as the commit message. I changed one file, had 9 lines of text, and the umask, if that terminology is familiar to you from manipulating files on a Unix file system before, has 644 as the umask. That means the user can read and write it, and the other and group can just read it. That's the default creation for a file. So this file is now a permanent part of version control, and git status would further report that I have nothing to commit, the working directory is clean. I emphasize again that nothing is running in the background, so when I type git status, it examines the entire file system of this project1 folder and everything beneath it. The same goes for when I type git add and choose a file, and the same goes for what's in this staging area or shopping cart when I type git commit. It's taking the previously added items, the ones that I've already chosen, and making those a permanent and committed transaction. That's pretty good from the command line, but you're now probably yearning to see some sort of graphical user interface on top of this, and I can happily do that for you. I'm going to go over here to GitHub for Mac, which is one of our GUIs, and I'm going to add a new local repository and point it over at my Scratch directory. So let's go over to my Scratch folder here for just a second and browse right into Project 1 and add this as a repository that is paying attention to. What you see now is that I have some uncommitted changes. No, actually none whatsoever. 0 files, 0 additions, and 0 deletions. But could I look back at any of the history? Why, of course. On the top left side, I see my first commit. What I can emphasize here is that there is absolute symmetry because everything is committed to disk in the .git folder, from GUIs to the command line. You don't really have to press refresh or have it reload a database. Everything about the Git repository is stored in that single .git folder. GUIs writing to the same thing, command lines writing to the same thing, mix and match as you choose. Open up Eclipse, go over to the command line over to GitHub for Mac, or in a minute, even GitHub for Windows. I'll show you how we blend all three. Now, we've seen a basic introduction of using Git at the command line, but you must feel that there is just an ocean more to learn, and you'd be correct. And what I very delightfully can point you at is that there's a free book to guide you through probably about a couple of months worth of study if you wanted to actually put that much effort into knowing all the intimate details of this version control system. It's pretty fun when you can point at a high-quality free book, and this one is written by my colleague, Scott Chacon at GitHub. I've got all of these reference materials linked up after the webinar in a URL that I'll put back into the chat room again. I did so right before the webinar started, and I'll do so at the closeout of the webinar again. But gitscm.com/book is a really well-written introduction to this version control system. Additionally, if you get so energized about this stuff that you'd like to look through other class notes that we've taken, little step-by-step instructions, kind of a quick welcome, some videos that we've put together on learning these same things, that is actually all housed over at teach.github.com. So if you were already wondering, well, this is maybe pretty good, Matthew, but I sure wish there was something that I could view offline or take a book in EPUB or Mobi form and throw it on a Kindle or an iPad or something like that, well, we've got you covered in all of those places. And in fact, even these online videos that you can load up and watch and get the basics of GitHub mastered as well. Now, we need to do something on the GitHub side. It's about time, but it's intentional that I left it this long before we actually involve the network whatsoever. You have completely been able to isolate your thinking to the local disk and to the local machine, creating a repository, looking at its contents, and then adding some new materials to it and looking at it with a GUI and perhaps adding changes from that. But what about getting it to your colleagues? We haven't really covered that at all. But the nice part is it is so simple and so easy to layer this on top of what I've already shown you. I'm going to go over to Firefox and to Chrome as two browsers, and I'll show you why I want to layer each of these two onto your screen. Now, I have in this upper left-hand corner, I have Firefox, and in this bottom right-hand corner that I just drug onto the screen, I have Chrome. Why am I opening up two browsers, and why am I showing it to you in this way? Well, in the top left, I'm signed in as a GitHub trainer. And in the bottom right, I'm signed in as a GitHub student. And what this will allow me to do is to show you a real-world use case of where I'm manipulating two different repositories. One as kind of the boss or the owner or the manager or the director or the senior engineer, and then in the bottom right, acting as a student for how would you join us? How would you help out with one of these projects? How would you collaborate? How, if you found an open source project up on GitHub, would you be able to offer your contributions to this project? Well, that's exactly what I intend to show you because open source really is a collaborative effort and it needs your help. So what I'm going to do is I'm going to go through the motions of choosing a repository that this trainer owns on the upper left, Hello Git World. And on the bottom right, a project that you might want to join, that you might want to collaborate and add yourself into. And what I'm going to do prior to this, and that's what I'm ultimately getting to in about 5 minutes, is to show you how to preserve that work to close out our thinking, to preserve the work of Project 1. So two different modes that I intend to showcase. One, preserving the project that we already worked on, and two, showing you how to collaborate on a project that already exists. Let's set our attention to publishing this Project 1 first. First and foremost, it has no knowledge of any network destination yet. So let's, as a student, go over here to our GitHub student Chrome browser and click Create a New Repository in this top right-hand corner of a free account at github.com. It says, what would you like to call this? And I'm just going to say very lazily, I'm going to call it Project 1. Seems good to me. The checkbox indicates that name is available, and I'm going to make it a public repo so everybody here in class could potentially see this. I'm actually going to ask you to participate here in the next couple of minutes, and I'm going to create this repository completely empty. You'll in fact find that there's some instructions down here, but the critical one is the second set of steps that says, how do you push, how do you transmit or preserve what we've done locally on our command line up to this centralized repository? Well, it says copy and paste these two instructions and head back over to your command line and paste these two instructions while in that Git repository. It added a remote, which can be thought of as just registering a bookmark for that long address that represents the GitHub destination. And then it pushes, which is Git's verb for transmitting the contents of the local repository to some other place over the wire. I'm going to type in my username and my password. And that repository has now been transmitted, and you in fact see that it says a new branch, master to master. That's been transmitted, and in fact, it is so quick that if I simply refresh the view over here, you see our first.txt showing up in the browser. Now, what's also important to note is that it says it was authored 9 minutes ago, but what? I just pushed the contents of that repo. It preserves and maintains the timestamp and the order and the people and usernames of the work that had been done on your local disk when you push. You can think of it almost as just synchronizing. It's already captured all of the data for the commits, the transactions, the changes to code, the who did it and when you push, it simply is synchronizing those local activities up to a central repository. All right. We can kind of clear our heads for just a moment of preserving our project one. Let's change modes. Let's talk about working on, joining, and participating in a project that already exists. Hello Git World needs our help. So someone emails us an address to this and said, GitHub student, could you help out potentially with this Hello Git World project? And I say, well, sure, of course, but I have a little bit of a problem. You haven't given me any privileged access to work on this repo just yet. I see that I have read-only access to this repo. So what do I do? Do I ask for authorized credentials to be able to change this? No, I don't. In fact, on many open source projects, it's upside down. You simply begin helping and then later ask for the privilege for your code to be folded in once you've completed it, or at least made a meaningful enough contribution to start to ask for inputs or code review. So as the student, I'm on this global repository, and I'm going to click fork, which allows me to make a copy of it to my personal namespace. I'm getting a full photocopy of the repository to my personal account. Now, many people of 10 years ago would call this extremely rude. Oh my goodness, he's now taken a personal copy and he's going to do whatever he wants with it, which means none of the value that this student creates is ever going to go back to the central repository. Well, that's not true, because as soon as we start making changes to this, I am going to offer them back to the core project. I'm going to grab this address, copy this to my clipboard right here, and I'm going to return to the command prompt wearing my GitHub student hat. I'm going to step back out of project one because we have put that one behind us, having preserved it to github.com, and I'm going to type git clone and supply this address. It is going to assume by default that I want to call this on my local disk Hello Git World as the folder. You can in fact see that when I list the directory right here. And as I change over to Hello Git World, like I did right like so with the CD, I can now ask questions of this repository. It is a full-fledged repo with all of the history and all of the branches brought to my local disk. I can actually show you this by doing a git branch -a, show me all the branch names. And there you see that I brought over dosug features and a bisect feature, an image that I've done on the web, subtraction features. All this work in progress on this project has been pulled to my local machine. Unless I emphasize it, I'm referring to local instructions. So let's start ourselves a new branch. Let's call this new branch a November class feature, a nice little descriptive name. And then let's proceed to check out. That is the instruction for toggling to a branch. Let's check out to the November class feature branch. That switches the entire contents of my local directory to represent, to be, and to have the state of the November class feature branch. But at this point, the perceptive ones amongst you have realized there's zero difference between the master branch that I was on by default and this newly created branch. There's nothing whatsoever that yet differs between these two. Now, I'm going to, for just a second, take this window and no longer make it full screen. I'm going to slide it over here to the left-hand side of the screen, and I'm going to open up another Finder window that I'm going to get ready for you here in the second pane that I'm working with right now. I'm going to get my way over to the same Scratch directory. I'm going to browse it with the Finder view here in just a second. And you're going to ask me, well, why would you want to show me this? Well, you're going to see, as I'm drilled into this Hello Get World 1, and as I put it onto your screen like so, that when I create a new file, you're seeing this. Let me minimize some of these other windows so as to kind of reduce the noise in the background so we don't have to have these other applications at all participating in any confusion. There we go, a nice little reduction. So what we have is a view over to this file system right over here, and everything else kind of shrunken out of the way. I'm going to create a file while on the November class feature branch. Watch this. I'm going to just take a text editor once again and create a brand new file on the branch.txt. I know, I'm being a bit silly about the file name, but that'll work. And I'll put a little bit of HTML into here just to kind of pseudo-represent that I'm writing code. I'll save and close that text file that I've just created there. And here, you see it. In this Finder view on the right-hand side, zero surprises whatsoever. Here I have it on this Finder view on the right-hand side of my screen. Now I'm going to pull this up a little bit higher so you can see the other files that are participating. And I'm going to ask Git what it thinks about for a status perspective. I'm then going to Git add this brand new file. I've put it into version control, and you've already seen these recipes. These are the same instructions that I ran when I was using the version control system in purely a local thought process. Git commit -m, and I'll say a new branch file. I've now saved that to disk, but it's not yet on the network. It's not yet up on github.com, and you may recall that the verb I said allowed us to interact with the network was push. We're about to use it. But I'm going to git push -u, deciding to publish for the very first time this new branch. These new branches, like November class feature, are an opt-in process. I'm going to type my credentials, GitHub student, and my password, and that branch is now published up on GitHub. But why opt in? The idea is to create branches for just about any small thing that you'd want to do, whether that be a bug fix, whether that be a long-lived feature branch, but I hope not too long-lived, and then to contain this work to be able to have some code review and discussion on it. That's what you're going to see next. I'm going to do one more thing, though, before I leave this command line, and that is to git check out the master branch. Now, as I do so, I would like to call your attention to that right-hand side of the screen. Please look at that Finder view and watch the file disappear. You just saw that file, a brand new file on the branch.txt, disappear from the file system. And I believe this is very helpful in getting the mental model and picture of the fact that when you check out a branch in Git, it is updating the file system to reflect the state of that branch. Adding files, deleting files, reverting them to an old state of code. But when you check out a branch, all of the files become up to date with that exact branch that you've just checked out, whether that means deleting, adding, or modifying files. But I can equally return and git check out that November branch just like so, and the file appears once again. The .git control folder contains all of the branches and can rehydrate them at any point in time. I'm going to bring back Google Chrome over here, and I'm going to refresh this browser page, and you will see that I have a new branch that I've created, a November class feature branch that is one commit ahead of everything else that's been done in this project. I'm going to go look at that branch, kind of see what's been happening on it. Oh, the most recent change, a new branch file. Not much of a surprise there. I think I'll offer this amazing new feature that I've coded back up to the central project maintainer. I'm going to click on the pull request button. A pull request is a fundamental unit of work on the GitHub side of things. When I say GitHub side of things, I don't mean that we've written a custom version of Git. I don't mean that there's any special protocols or any special thing other than a very, very handsome UI on top of the fundamental features of Git, branches, and merging. This pull request is offering my student change into the core project maintainer. You can in fact see the arrow in the middle right here indicating the direction of travel for this suggested change. And many of you may now, or even after class, challenge the use of the phrase pull request. Why is it a pull request and not a push request? Because this is once again inverted the permissions model. I did not have to, as a student, ask for the rights to contribute to the project. I could make whatever change I wished. But those changes are not folded in to the official copy of the project until one of the core maintainers or authorized engineers decides to bring them in. I'll make a polite request in which I describe why this should be brought in. So, what I've just done is I've written out a quick little description, of course it could be a bit more technical, as to what I'm offering to the core project maintainer. Over here on the commits tab, I can see which units of work I'm offering in. And on the files changed, I can see a summary of the code that I'm suggesting the project adopt. With the pull request, I'm going to send this in and queue it up for the core project maintainer to potentially act on. Now remember, I had the two hats that I was wearing, a student, and then in the top left-hand corner, a trainer. I'm going to go to the list of pull requests, and I see right over here a new branch file. And you know what? I've already been trumped. I've got someone who is offering 110% better sparkles. So let me look at this pull request from one of our students in class. Let me tell you, this just delights me to actually see this happen in class. I'm going to look through this. I'm going to see a new branch file. I see that there's one commit. Lipsum. Absolutely. I cannot avoid taking Latin. So I'm going to merge this pull request and fold it into the core of the project. What have we just done? We have done something ridiculously transformative to the software world. This applies not only to open source, but to your own closed source commercial software. This means that people who before were kind of on the line of, should we give Matthew access to this project? I don't know. He's not really that familiar with it. Stop having that discussion. Give the core set of engineers direct access to make changes to the code, but give everyone else this privilege to issue pull requests. There's a governance, there's an opportunity to review and discuss, and these changes then have a nice little gate to control them going into the core of the project. You can reject them, you can approve them, you can see if they're good changes, you can even have an analog debate with these contributors. Let's say, for example, I want to argue with myself and my other hat that I'm going to go back over to this right box and say, not quite what I hoped for, but with a few more hours of polish, this could work. That is an analog response that is so important here because rather than outright rejecting the change, I can fire a message back over to the author of this pull request saying, I really appreciate what you did. There's a few little things that are keeping me from accepting your contribution, but if you could make these changes, I'd be happy to accept it. And so that GitHub student could return to the command line and open up that text file that they were making changes to, and they could insert that additional little bit of changes that was requested by the code reviewer. They could save those, they could add those to disk, and they could commit those, polish, that'll be good enough, and they could push those changes back up. And having pushed those changes, what you'll see while I just literally hang out on this web page, I'm not even going to press the refresh button, is that you're going to see those code contributions come in time sequence order. This means that what you're actually doing is discussing in a previewable, shared, kind of collaborative way code changes that are being suggested to the product, and you can have these analog, very close, but we'll see. Quite, not sure. Oh, with that polish, I'm ready to accept it, and then I could merge those changes in. Now, I'm going to be a bit angry here for just a second and say, you know what? You're just not heading the right direction. I wish you had listened, but we are not going to repaint the UI with blink tags at this time. Sorry. And put a little frown in there and close and comment on that. And this is closed. We're just not going to do this. So it works either direction. It's an analog debate with a yes or no eventually at the end of this conversation. That is a way to democratize software contributions. Now, you've seen an awful lot of demonstration. And what's helpful is to say that even though we only peered at one of the GUIs, I'll poke at a few more and show you what they look like, that there is just an ocean of choices of graphical user interfaces for you to choose to accomplish exactly the same things that I did from the command line. Now, why show the command line, Matthew? Because like learning a language, you're finding out the nouns and the verbs and the exact addresses that you're working with. And when you transition over to a GUI, I think it will be exceedingly easy because you'll know what belies those button pushes. What is a push doing when I click the push button? What is a clone doing when I click the clone button? And you know the answer to that now, having seen it from the command line. You've seen me on Mac, but you haven't yet seen me on Windows. And now's the time for me to toggle over to my Windows instance that I have up and running. Here I am on Windows 7, and I can do a quick little look at what repos I have beneath my GitHub student or GitHub org account. I can look at these repositories and I can choose one. Let's say, for example, Hello Git World down here from one of my colleagues that I have privileged access to, or Class Demo 1, or this Git Scribe project. And a quick click of the clone button brings that down to my local machine. Look at the process, look at the progress there. It'll save it to local disk in exactly the same format and compatible format as if I had cloned this from the command line. A project directory, and then a .git folder beneath it to house that data. I can even then jump into that project, open that repo, view the history, see what's been happening to this lately. You can see this one is much richer than just the Matthew and the student participation. Here's Scott and Nick Quaranto participating, some other folks like Chris Strom also contributing to this project. And this is the same kind of participation, but in a purely GUI sense. And this is our GitHub for Windows client, but you now know what belies those button clicks. And to me, that's extremely important. Now, having seen those demonstrations of those two GUIs, you might ask even further, is there kind of a compromise where I could use like Notepad for some of it, graphical, editor, but then continue back to the command line for some of the other instructions? Why, of course, there's something else that we develop at GitHub called Gitpad that provides exactly such a hybrid little bridge between the two. And there's also a first-class citizen. If you work in the Java space or anything else on which derives from Eclipse, the IDE, has a first-class plugin called eGit that now shipped with this summer's Juno release. It is the default version control system for the Eclipse space and now ships with the Java distribution. So you bet. Visual Studio, likewise. There is a Git extensions that works with Visual Studio and plugs in and offers the same kind of right-click checkout functionality that you've been seeing me type longhand, but instead gives it to you inside that Visual Studio 2010 or above IDE. This model that we've been talking about for collaborating, whether through a GUI or through a command line, and then using that web page kind of view into what's been happening with the repos, has a formal name. And we call that social coding. I think that's embodied by the fact that you're getting more people to participate and review rather than fewer. And it operates on this fork and pull model. Something that maybe some of your friends would say, oh, forking, that's bad. You're taking your own copy of the repo and doing with it as you wish. That's probably the downside. But the good side is when you offer those changes back in and they become an official part of the project, thus nullifying that complaint. If you needed a picture to kind of put this into a diagrammatic form, it would look something like this. The ability to have anybody take a read-only, hence the gray lines, copy of the repo, to pass those up to someone who is privileged enough to do the code review, to fold it in and to have a discussion with perhaps the one or several people that are the project owners, and to have the purest of those contributions folded in to the official copy of the repository. Nobody had to be granted privilege of being able to clone the repo in this model. When said about closed source, your product's businesses, what I mean by this is that any employee who works in the software space could make a clone of the repo and offer it then perhaps to the trusted senior engineers or the people who are responsible for performing deliveries of your product. In the open source world, I literally mean anybody, the blue icons at the bottom, can clone it and then offer it to the core project maintainers. I think that's fascinating to see, but you are right in questioning, does it really work? My favorite example is the Grails project on the JVM platform. 5 times the meaningful contributions once switched over to this model. That's a statistic that simply cannot be dodged. It is amazing. 5 times the contributions when switching to this approach. Now, you think that I've shown you graphical clients and I've shown you some desktop clients, and maybe that's about it. You've got a web-based view and some places that you can actually commit and check in code, but I would actually be missing out if I didn't point out a few more incredible things. I'm going to go over to this Hello Git World repository, and I'm going to look at one of the other branches that I already had set up, and one of these other branches down here is called Feature Image. Now, typically we've been conditioned to think of command line, command line, command line. We need these tools and then graphical user interfaces for doing things like diff. But what if you needed no desktop tools to review the most recent commits? And in fact, to see not only the differences in code, I think we have kind of a feeling and a sense of what that looks like side by side, but in fact, an ability to review the changes to graphics as well. This is a before and after of an image that I've checked in. It works with PNGs, JPEGs, TIFFs, BMPs, GIF images. And what I can do is with 0 plugins, 0 desktop tools, I can review the differences between images that perhaps the design team members of my organization are contributing to this project. I can even run a difference engine to have highlighted small things like a copyright logo or a trademark symbol that was moved from one corner to the other. And I emphasize you're doing this with 0 tools on your desktop. This is a purely web view. And I think that that is transformative because people were, oh my goodness, kind of burdened with the what have I got to load to be a productive developer on this environment? I've got to load this desktop tool and that desktop tool and a diff engine. Got to register that, make sure it's hooked into just view the web view and get the majority of the things that you were previously doing on a desktop set of tooling. If you're in a place, an organization, a business, or an industry that's constrained, that is not allowed to put this kind of stuff on the web, maybe you're both excited to contribute to open source, but then you're frustrated because you're never going to be able to use this at your job. And I will tell you that's not the case at all. Many US and foreign government agencies that I've had a delight to be able to teach, many medical institutions and financial institutions run their own copy of GitHub inside their firewall with GitHub Enterprise, thus nullifying any concern of using this .com that I've been showing today. A whole on-premise copy of everything that I've shown you already in today's class. Now, as a last step, I'll mention that this is just an introductory piece to Git. There is literally, I want you to feel there is literally months worth of learning ahead. And I want that to be a source of delight, not a problem. This is something where you can use it for work with just a day or two worth of practice. But then a week or two later, you're finding some advanced moves. A month or two later, you're finding the way to rewrite history, to shape your commits, to squash them into better delivery units. And so it's kind of like peeling the onion. You can absolutely get your job done in a day or two worth of practice on this, but there is literally months, if not years, of features that you can unravel that make you more and more productive in using it. Thank you once again.